Hi everyone, this will be your video for transformations of all parent functions. So you're going to see a nice variety here of all of our different transformations. So here's a list that you should copy down into your notebook of the different types of transformations that can occur to a function. So the first group that we always talk about is a reflection. And we're going to talk about how we know this, but just so you have an idea of how our functions are moving, the first thing we could have is a reflection. So we could have a reflection over the x-axis or a reflection over the y. The reflection over the y is much less common. You most often just see the reflection over the x-axis. Our next type of transformation that we have is a translation, which you might remember from geometry, and that's just really a slide. Okay, so you can have a vertical translation, which means that you might be going up or down, or you can have a horizontal translation, which means that you're going to be moving left to right. Our last type of transformations that we have on functions is a dilation, and our two options are a vertical stretch or a vertical compression. So we're going to get into what that looks like next. Here's your general form of an equation. And in this general form, we can find all information we need about this graph, knowing what happened to it, the transformations, without actually graphing whatever function we were given. So this first value right here, A is responsible for reflections. A is also responsible for if you have a stretch or a compression. Okay, so you can have a reflection and a stretch or a reflection and a compression at the same time, but you can't have a stretch and a compression at the same time. That just doesn't work. So you have a reflection when A is negative, and that's a reflection over the x-axis. You have a stretch when the absolute value of A is greater than 1, so it's a value greater than 1. And you have a compression if that absolute value of A is between 0 and 1, so you can think if it's a fraction or a decimal. But you do need to make sure that you're not getting tricked, because sometimes you can have a fraction that's greater than 1. So just make sure that it's compressed if it's a value that's less than 1 or greater than 0. So that's our A here. It's telling us if it's reflected over the x-axis. It could tell us if it's stretched. It could also tell us if it's compressed. Let's talk about our H. So when we're looking at H, this one is a little strange because it's going to be a little bit of opposite thinking. So H is for horizontal movements. So horizontal translations. There we go. So horizontal translations. So this is the one where you have to think opposite. So I'm going to write this here in quotes. So think opposite. And with that, if you see, dot, dot, dot. Okay, here we go. So if you see a plus H, you're really moving to the left. If you see a minus H, you're going to be moving to the right. So this is where you really need to think about the opposite of what you see. So if you see a plus H, you're going to be going to the left. So it's kind of against your intuition. And that just means we're taking the whole graph and sliding it all to the left or sliding it all to the right. Now our easiest transformation that we have visible to us in this function, that's going to be this K value. Okay, so I'm going to bring K all the way down here. So K is going to talk to us about vertical translations. And this is just whatever you see, you go with. So we have our vertical translations. So this is just go with it. Okay, so if you see a plus K, that's moving up, or a minus K, it's going to be going down. So like I said, this one's the most intuitive. It's just whatever you see. So if you see a plus K, we're just going to be moving our whole function up that many units. So just to give you an idea of what this might look like with an actual equation, because I know this one's just very general right now. So an actual equation of this, we'll have a couple examples down here. So we can have, let's do this one. So we can have this function, f of x equals, and we'll do a negative, we'll do a parabola on this one. Okay, so you can see how you have your h, which is on the inside, you have your k, which is on the end, and your a is in the front. So a, h, k. You can also see this, we can be working with a cubic function, so we could see like, we'll do x plus 1 cubed minus 2. So that's a cubic function. You can see how you have your h on the inside, which is a plus 1, k on the end. A is a 1, okay? So if you don't see anything, it's just a 1. You could see an absolute value function. So let's do an absolute value. So we'll do some little extra on this one. Okay, so you can see now I have a value for a, and this is between 0 and 1, so this is going to be a compression, and we're going to get into that in a few minutes. So I have a value for a, which is 1/2. I have minus 1 for my h, and k is on the end. So we're really going to be focusing on what's on the inside of the function and what's on the end or in the beginning. And when we're talking about the function, we're talking about what operation is really happening here. We're squaring our x, we're cubing our x, we're absolute valuing our x. And one other one you might see is a radical function. And that could look like, you could have something on the inside and also something on the end. Okay, you can also still have an a value here if you wanted to do, you could do this one. That's like one of those tricky ones I was telling you about, because this looks like a fraction, but it's actually greater than 1. So this is a stretch. You have your h, which is plus 2, and your k, which is minus 1. So here's some examples of functions that you might be seeing today. Okay, so to get started, we're going to start with a reflection over the x-axis. So what you see here is that the black parabola graph is our parent function, and the purple one is our reflected function. So you can see that the difference in the equations, it's only that this has a minus sign in the front, a negative sign. So if our black was our original parabola, to get my secondary one, I would just reflect it over the x-axis. So it just got turned upside down. And this can work for any of our functions. I'm just showing you a couple of examples here. So parent function, transformed function. We have a negative in the front, so that means that it was flipped over, reflected over the x-axis. We also have horizontal translations. So again, the black function is our original, our parent function. So this parent function is our x cubed, which is a cubic function. And we have two other cubic functions on here. So the red one, if you look, has a plus 2 on the inside. So that's in the place of h, right? And with h, we had that weird little rule where it said think opposite. So this plus 2 right here is telling me that it's going to the left 2 units. So you can see if I were to take my original center point here and moved it to the left 2 units. So I moved it to the 1, moved it 2 units. You can see my whole graph was slid over 2 units. Now we also have the same idea for our third function on this page. And with this one, now we see a minus 2. So this minus 2 is telling us that it's going to go to the right 2 units. So I took my original function and I moved it 1 unit, moved it 2 units. So you have left when it's a plus h and right when it's a minus h. Okay, so still sticking with translations here, now we have vertical translation. So again, we're working with a parabola. The black parabola is our parent function. Okay, it's just x squared. Now you can see that for my red parabola, it's x squared minus 1. So just like we used our horizontal and we said, okay, we're just going to slide this whole thing, same idea now, but instead of it being left or right, we're going down. And this is just intuitive. I see a minus 1, so I know that I'm going to be going down 1 unit with all of my points. So down 1. Now our blue parabola has a plus sign, so this is going to mean that we're going up 1, or however many units you see there, whatever your k value is. So for our blue parabola, we took our original function and we moved everything up 1. All of the points got moved from end to end. Everything is moved either up or down. Okay, and here's our last transformation before we kind of put it all together and view them all at one time. When you're looking here, we have absolute value as our parent function, and it's going to be the black V-shaped graph. Then we have a red and a blue. So the red one, you can see that in our spot for A, we have a 2. Now 2 is greater than 1, right? We've learned that for a while now. So this is greater than 1. So it's stretched. So what you need to think about is if somebody was holding onto the ends of this absolute value function and pulling them vertically stretching them, it's going to get narrow, it's going to get skinnier, and it's going to get taller. So this is our stretched function. And then we also have down here where we have a 1/2. So if we have 1/2, this is between 0 and 1. So that's a fraction. So this is going to be a vertical compression. So what you can think about when you're thinking about a compression is if somebody had their hands on the top and bottom of your graph and they were squeezing their hands together. If you ever watched any of those hydraulic press videos, it's the same idea where it's squeezing together and your function is going to get wider and flatter. So this is our compressed function. So really visualize like somebody's either squeezing your page for compression or stretching your page for, obviously, for the stretch. So here's an example of putting a lot of these ideas together. This is a radical function. Our parent function is the original one down here. You can see that its endpoint is at 0, 0. Now if we look at our example here, we need to figure out what this is asking us. So let's take a few minutes and figure out what this is asking us. So this is saying, okay, my A is a -1. So that's telling me I'm going to be reflected over the x-axis. So I always try to just like kind of like how you read, and we read left to right. So I'm just going to work through this equation left to right. The first thing I see is a -1. So that means it's going to be reflected over. Now the next thing that I see is this +3. So that means at my H, I see a +3. So what that's telling me is that I'm going to go to the left 3 units. Okay, so I'm working my way down the equation. You can see how the x plus 3 is really in the radical sign and the +1 is on the end. So that value on the end is our k. So our k, what do we see? We see a +1. So that's telling us that we're going to be moving up 1 unit. So as we look at our graph, we can really see the steps that were taken to get from our original parent function to our secondary or transformed function. So I'm going to be doing this with, hopefully it'll look decent enough, but with dotted lines, so you can see how did we get from the black one to the red one. So the first thing that we noticed was that it was reflected. So now our graph is turned upside down over the x-axis. So here is my reflection. I did that in purple for you. Do it over here so you can see what color that was. So then we saw, okay, the H told us it's going to be moving to the left 3 units. So what that means for me is I'm going to take every point and I'm going to move it to the left 3 units. So I'm going to take this endpoint right here and I'm going to go 1, 2, 3 units. So now I have, this is my function. Okay, and that was done in blue. So I moved it to the left 3 units. So step 1, I reflected. Step 2, I moved it to the left. And then the last thing we have to do is that we have some sort of vertical shift. We have a +1 as our k. So that means I'm taking this and I'm going to be moving it up 1 unit. And it's already graphed for us in the red. So you can see that we can really break down equations and know what's happening in a graph without having to be able to graph these ourselves or creating a table or anything like that. We know how to transform, how to slide, stretch, compress, all of that we know just from looking at the equations now.